Hi, welcome back to lastprep. In our previous video, we learned what large language models are. Today, we are going dive deeper into the part that actually creates intelligence inside these models. Right? The topic is about pre-training. If LLMs were humans, pre-training is like those first 18 years of life, learning language, grammar, facts, concepts, common sense, logic, just by reading and observing the world, right? So, in the next 10 to 12 minutes, I will explain how pre-training works really, why it's important, and how huge models like ChatGPT and LLaMA and Gemini can learn from the massive amounts of text in the real world. Let's begin. What is a pre-training? What is pre-training? Pre-training is the first major phase in building a large language model, right? If I say definition, what is pre-training? Pre-training is when the model learns the general language patterns, grammar, facts, reasoning, context, and world knowledge from the huge amount of text. If I say simple example like by using a child, think of it like giving a child a like full of books in the library and letting them read everything for years. After finishing by reading, the child can answer the questions, write the stories, and summarize the paragraphs and reason about the world, even without being taught specific tasks. That's exactly what LLMs can do, right? If I say a simple real life example is like a GPT 3, like it is trained on huge amounts of data, so it can on the number of books, Wikipedia, and also websites and GitHub codes and Stack Overflow and scientific articles and totaling hundreds of billions of tokens, right? And this is what what is pre-training means really actually. Why do we need a pre-training? First, LLMs must understand a language before performing the task. That's why we train the large amounts of data. After that, without pre-training, they cannot answer the questions and generate the text or reason. Pre-training builds a universal foundation for all the future tasks. Like we can write the code and do the sentiment analysis and also writing something and generate the text also, right? Helps the model generalize to new tasks, new topics it has never seen. And also it can generate new images also by based on the more number of images that was trained for the LLMs. And it turns raw text into useful internal representations, right? If you say the GPT-3 real example, it will be trained on the huge amounts of Wikipedia data and also GitHub, Google Books, and a Common Core, right? And also more websites and the data also. That's where the pre-training can be done based on the large amounts of textbooks, Wikipedia, and encyclopedias, and also different kinds of data that is available around the world in the internet, right? Next, the data for pre-training. To build a model that understands the world, we need high quality diverse text. We need high quality diverse text, right? Think of LLM training like just simple preparing the food, right? We need ingredients and cleaning and cooking and tasting. That's where the pre-training can be done also in the real world. Ingredients equals to the raw text, the massive diverse data sets from web articles, blogs, and encyclopedias like Wikipedia, books, fiction and non-fiction, research papers, code repositories, and GitHub and Stack Overflow and news data and multilingual websites, right? And also the forums, research papers, and web data like common crawler data. and news articles also there. The main goal is like cover a wide range of human knowledge and language styles, right? The larger the data and the cleaner the data, it should be better for the more intelligent models, and more data means the better the model, like LLM models. So it can generate the accurate results for the people. After that, we have to do the some process like data cleaning. In the after gathering the data, we can done some process, some steps like data cleaning, and also like tokenization. Tokenization. These are the important concept in the pre-training phase, right? In the data preparation and cleaning, here we have a large amounts of text, right, gathered from the various sources. By in the data, we have to remove the spam, duplicates, and low quality content, and clean the HTMLs, and remove the ads, junk text, and broken the sentences, and remove the harmful, offensive, and biased data. Normalize the text like punctuations, encoding, and Unicode fixes. After that, filter out the irrelevant content, URLs, random numbers, and noise also. The final dataset becomes a highly structured and mission readable format, right? This is the whole process of data preparation and cleaning after gathering the massive amounts of data from the around the world, right? After that, we done the tokenization. After data preparation and cleaning, we done the tokenization. Like the text, here the tokenization means the text is broken into tiny units called tokens, like small units called tokens, like convert the text. Models don't read the sentences, they read only the tokens, right? If I say a simple example, artificial intelligence is amazing. There is artificial is became one token, intelligence became one token, and is and one token, amazing is one token. This is what the tokenization can be. Then the models do not read the sentences, they process only tokens, right? Tokenization makes everything uniform and understandable. Like it reduces the vocabulary size, maintain the consistency, allow smooth processing in the neural networks, right? And this is the process of pre-training in the in the early stages, like early stages of pre-training. The data can be cleaned and tokenized. After that, the models learn during the pre-training. How the models learn during pre-training? Like this part is most important and heart of the pre-training, right? The most LLMs learn using a very simple idea called self-supervised learning. The core idea behind this is the model learns by predicting missing or next words, just like solving millions of fill in the blanks puzzles, right? No manual labels are required, right? We have two main strategies called next token prediction, like GPT models and master language modeling and the BET models, right? For example, next token prediction is, for example, if we take a input like the sky is a dash, the model learns to predict the sky is blue. That is our next token prediction. The masked word prediction is like the cat sat on the dash. Like here the mask, we have to predict that masked word. What is that word? It really the mat. The cat sat on the mat. It is a masked word prediction, right? The predicting the word teaches like why this works means the model naturally understands the grammar, context, relationships, logic, and long range dependencies, and also reasoning, facts, sentence structure, and relationship between the concepts, right? LLMs do this billions of times per second, right? Like billions of predictions, a deep understanding of the language. After that, the main architecture is a transformer architecture. That is the base for the LLMs. Based on the transformer architecture, the LLMs can be done. To understand a pre-training, you must know the engine behind the LLMs, right? The transformer architecture. Why the transformers are very powerful or powerful means it is like a backbone for all the modern LLMs. It uses, they understand the whole sentence at once, the whole sentence parallel processing, like the process the whole sentence simultaneously in the parallel way. like uh, they use attention, a mechanism to focus on the relevant words, and also they scale extremely well. Okay, the attention means here lets the model focus on important words automatically in the sentence, right? If I say a simple analogy, imagine reading a whole paragraph and instantly knowing which words related to which. In the same way, transformers do this automatically using the self-attention mechanism, right? If we say here, the lion that chased the deer was hungry. The main sentence here, the lion, the model must connect lion. Lion was hungry, not deer was hungry, right? The lion was hungry. The model, the transformer architecture uses this mechanism, learn this automatically, right? The attention mechanism learn this automatically because on the based on the relevant and simultaneously do the parallel processing and focus on the most important words automatically, right? After that, the training process, how the training loop works. Now let's see the actual training loop. Even though this sounds complicated, I have simplified this in the right way, like by step process. Steps are repeated trillions of times in the pre-training process. The first step is take a batch of tokenized text as a input, feed into the transformer architecture. After that, the model predicts the next token, missing tokens. After that, compare the predictions versus actuals and compute the loss or errors. Prediction versus actual. After that, calculate the loss, right? Computation errors. After that, use the back propagation to update the weights, right? To adjust the weights or update the weights. After that, update millions of billions of parameters. After that, repeat 1 trillion times and more also, and move to the next batch. Like this is the whole training loop works in the pre-training process. Over the time, predictions become highly accurate. This is how knowledge gets encoded into the model. Next comes into picture of hardware part. The most important thing in training or pre-training the models in the large language models is the hardware part in the infrastructure. Pre-training requires a massive hardware, thousands of GPUs, TPUs, and sometimes TPU also. High-speed networking between nodes, parallel and distributed training, petabytes of fast storage, specialized frameworks like DeepSeed and DeepSpeed and Megatron, LM and JAX also. Like a high-speed networking also we need. And the pre-training large language models cost millions to hundreds of millions of dollars, right? This is why only companies like OpenAI, Gemini, and NVIDIA and Meta can do the pre-trained use models. Like they have trillions of amount. That's why they can do the huge amounts of pre-training. After that, how the models can store the knowledge. This is where many people get confused. How the LLMs can store the knowledge in the way and which format. How the models store every bit of data. Like the model do not store text or copy paste content. Instead, they store the patterns, like they store only the patterns, relationships, and probabilities, and like inside in their neural network, like neural network weights, right? Similar to humans, do not remember full books but retain the concepts. The LLM stores like world facts, right? Language rules, cause effect relationships, and reasoning structures. If you read a simple example, if you read a 500 books, you don't memorize all the sentences, but we have to remember or learn the grammar, how the grammar should be in that books, and the writing styles, and the reasoning, and the cause effect relationships, and the language rules, facts about the like world facts about the world. LLMs do the exact same thing at a much larger scale. Like the LLMs can store the at a larger scale, right? Can store the patterns, probabilities, and relationships, and world facts, language rules, and all these things. The challenges are in the pre-training, like extremely expensive and time-consuming process, and requires huge quantities of the clean data. Removing the bias and harmful content is too difficult. Models may still hallucinate if training data is flawed. Scaling to billions of parameters demands complex engineering and environmental cost, also power consumption, right? Like huge cost cleaning the data, hallucinations, and scaling more data. Like bigger model means the more GPUs we need and the more cost. Right? Hallucinations means if the data is not perfect, the model may invent all wrong information. Like the model can hallucinate itself and give the wrong answers and the wrong information. Like after that, after pre-training, what the next process? Like pre-training is only the first stage, right? After this, the models are fine-tuned, like fine-tuned for specific tasks. Like pre-trained model is the foundation model or base model or base models. After pre-trained model, the fine-tuning can be done for the specific task. After that, aligned using human feedback means reinforcement learning with human feedback for safety purpose. After that, made safer using RLHF, and also instruction tuning for better responses, and do the fine tuning for domain specific fine tuning, like medical, legal, coding, and also for agriculture and different kinds of specific tasks. After that, it is optimized for reasoning also and coding also, like model compression and optimization for deployment also. Like, but without pre-training, none of this intelligence exists, right? Different types of pre-training in LLMs, like we have base pre-training and instruction pre-training, supervised pre-training, RLHF, like reinforcement learning from human feedback, and domain-specific pre-training, multimodal, continuous, and alignment, and different kinds of pre-training models we have. Like in base pre-training means model learns language and also world knowledge by predicting the next word from the huge text. This is where the base pre-training exists nowadays. After that, we have done the instruction pre-training. Like model learns to follow the human instructions, like summarize, translate, and explain. After that, supervised fine-tuning. Like model learns using labeled examples, like input and correct output format. And RLHF, model learns helpful, safe, polite behavior using the human ratings. After that, domain specific pre-training means like it can be particular field like medical, finance, legal, coding, agriculture. After that, multimodal pre-training. This model learns from multiple data types, like text, images, audio, videos, etc., like VLMs. These are VLMs. Continual incremental pre-training, like model updates its knowledge with new data over the time, like lifelong learning. And also alignment and safety pre-training, like a model learns safety rules, ethical behavior, and reduces harmful outputs. After that, preference learning or reward modeling. Like model can learn what responses humans prefer by ranking the outputs. Like there are the different kinds of pre-training types. So this is how the large language models learn language just like humans, but a massive scale. If this is helped you understand pre-training clearly, hit the like button, subscribe to the Last Prep channel, and comment what topic you want next. Fine-tuning, RLHF, embeddings, art of. Thank you for watching.